Okay, number 2 says write the prime factorization of each number. To do prime factorizations, you can just do factor trees. So if I was going to do a factor tree for 20, I could say it's 2 times 10. I can say 10 is 2 times 5. And then every time you get to a prime number, you should circle it, because that's where the branch ends. So I would say the prime factorization of 20 is 2 times 2 times 5. Or if you wanted to write it using exponents, you could do 2 squared times 5. If I want to find the GCF between 12 and 60, I can do factor trees. 12 is 4 times 3. 4 is 2 times 2. So I got 2 times 2 times 3. Then 60, I can do 6 times 10. 6 is 2 times 3. 10 is 2 times 5. So then 60 is 2 2s, a 3, and a 5. So then what do they have in common? So what's in common is a pair of 2s, another pair of 2s, and a 3. So if I multiply 2 times 2, I get 4. 4 times 3 is 12. So the GCF was 12. Some of you can just look at 12 and 60 and say, okay, I know my GCF cannot be bigger than 12. It can be exactly 12, because it's got to be as small as the smallest number. And then you can say, oh, 12 goes into 60. Bingo, there's my 12. So you don't have to show me all this factor tree business if you can do it in your head. So number 14, for 15y cubed and 20y. If you do it mentally, you can say, what's the biggest number that goes into 15 and goes into 20? Well, you know 5 goes into both of those. So I know 5 is the greatest common factor between 15 and 20. And then between the y's, they have a y in common. And you pick the y with the lowest exponent. So 5y is the greatest common factor. If you did it the long way, you write out 15y cubed is 3 times 5, and then y. And then negative 20y is 4 times 5, but 4 is 2 times 2 times y. So what they have in common is they have a pair of y's in common. They have a pair of 5's in common. So there's how you get the 5y. Number 16, Samantha is making beaded necklaces using 54 glass beads and 18 clay beads. She wants each necklace to have the same number of beads, but each necklace will have only one type of bead. If she puts the greatest possible number of beads on each necklace, how many necklaces can she make? So every necklace is going to have the same number of beads, but each necklace will only have one type of bead. So I need to find the greatest common factor between 54 and 18. So 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. 18 is 2 times 9. And 9 is 3 times 3. So what they have in common is they have in common a pair of 3's. They have in common another pair of 3's. And they have in common a pair of 2's. So 3 times 3 times 2, so 18 was the greatest common factor. So she's going to put 18 beads on each necklace, but each necklace only has one type of bead on it. So she has 54 glass beads. You can do 54 divided by 18 and get 3 glass necklaces. And then she has 18 clay beads, so if you do 18 divided by 18, you're going to get 1 clay necklace. And it says how many necklaces can she make? So altogether, 3 plus 1, she can make 4 necklaces. Okay, on section 7-8, you have to multiply x plus 1 squared, which means I'm really doing x plus 1 times x plus 1, which you can do a box for if you like the box method. I'm going to do the double distributive, so x is going to get multiplied by x and x plus 1, and then 1 is going to get multiplied by x plus 1. So when I distribute, x times x is x squared, x times 1 is x, 1 times x is 1x, and 1 times 1 is 1. So I can combine 1x and 1x and get 2x, and my final answer is x squared plus 2x plus 1. The shortcut for the square of a binomial is square the first term, so you get x squared. Multiply the two terms together, x times 1, double it, keep the sign that was in the middle, and square the last term. So that's the shortcut, and it still leads you to x squared plus 2x plus 1. For 12, 6p minus q squared means 6p minus q, 6p minus q. So if you like the box method, you could do a box. I'm going to do double distributive. So 6p is going to get distributed across 6p minus q, and negative q is going to get distributed across 6p minus q. So 6p times 6p is 36p squared. 6p times q is negative 6pq. Notice I put the letters in alphabetical order. And then negative 1q times 6pq is negative 6pq, because I'm going to put the letters in alphabetical order. And negative 1q times negative 1q is a positive 1q squared. So then I have like terms with a negative 6p and a negative 6pq, and I can get negative 12pq and get 36p squared minus 12pq plus 1q squared. And if you wanted to do the shortcut, if you recognize square of a binomial, all you do is you square the first term, so 6p times 6p. Since that's a minus sign, you're going to write minus. You multiply by 2, and you multiply the 2 together, so 6q times negative 1q, and then you square the last term. So you do a negative q times a negative q, which 6p times 6p is 36p squared. Negative 2 times 6 times q is, or negative 2 times negative 6 times negative 1 . Okay, I really should put plus here because I took care of the minus when I put the 1, minus 1. So I'm just going to ignore that, make that a positive 1. So this is going to be negative 12pq, because your sign, whatever the sign in the middle is, has to be the sign you keep. And then negative 2 times negative q is positive q squared. So you can do it either way. And then for 18, that's a special case because those are conjugates. So I can just do first times first and last times last as a shortcut. So 9 times 9 is 81, and then I would have to do a negative x cubed times a positive x cubed, so I add the exponent, so I get negative x to the 6th. If you did the box method, you'd get the same answer because your outsides would be a positive 9x cubed, your insides would be a negative 9x cubed, they drop out.